Okay, picking up exactly where we left off. So we have this. So the point is 1/3 natural log of 25, and the slope is 15. So y minus y1 equals m times x minus x1. Y minus 5 equals 15 times x minus 1/3 natural log of 20. Now, if all I've asked for is the equation of a tangent line, you can stop right there. That's an equation of a tangent line. We're going to check it and hope that this is right. So to check it, I'm going to need it in mx plus b form, slope-intercept form. So y minus 5 equals 15x minus 5 natural log of 20. And so y equals 15x minus 5 natural log of 20 plus 5. And there's the exact answer. And as I've said frequently, don't give me decimals unless I give you decimals. So we're going to check this. And we're just going to really hope for the best. So can we, there, you can sort of see that. Especially if we zoom in a little bit on it. So I'm going to put the original function in there, which was e. So if I do second and natural log, that gives me the e. And I'm going to put parentheses around it. So e, second and natural log gives me the e. E raised to 3x. If you have a newer calculator, it makes it look prettier. But I have an older calculator, so it actually uses the caret symbol. But the function was e to the 3x divided by 4. So there's the function. And then the tangent line I got was 15x minus 5 natural log of 20 plus 5. So I'll put the original function in there and then my tangent line. And we are just going to hope to God that this is right. So zoom 6, standard window, see if that does it for us. There's my function. And there's my tangent line. Okay, this is not a great picture, but I don't feel horrible because there's a possibility that this is right. So let's just play around and see if we can get a better picture. So clearly I don't need all this space over here, and I don't need all this space down here. That if we go back and I don't need all that space. So let's hit the window. Instead of going negative 10 to 10, let's just go negative 1 to 10, and let's try negative 10 to negative 1 to 10 on there. We didn't need all that negative axis. So graph it again. There's my curve. And it's thinking, it's thinking, it's thinking. There's my tangent line, and I actually feel okay about it. And I really don't think we're going to get a better picture because my exponential curve is going nearly straight up. And my tangent line is going nearly straight up. And so they're going so close together that we really just can't get the resolution we need to really see if it's perfect or not. But I feel okay as contrasted to something that's wrong. Let's get something that's wrong here. Let's just make the slope wrong. Let's say for some reason I thought the slope was 10. And I graph that, and let's see what that picture looks like. And I'm going to guess it's not going to look that much different. Yeah, okay, there. There's something that's wrong. That doesn't look like it's tangent. And especially if I do a trace, and the point was 1/3, and I'm just going to estimate it, 0.33333. That's roughly 1/3. For estimation purposes, decimals are fine. It was 1/3 natural log of 20. And there's where 1/3 natural log of 20 is on the curve. And so clearly that is a wrong answer. And so that feels bad. Now I'm going to try to graph this one more time. Instead of going all the way to 10, because I got all this blank space over here, let's maybe only go to about 4 and see what happens. So window, I'm only going to go to 4 this time. And then y equals, and get this back to the right answer, 15. So we're going to try to see if we get one better picture again. So there's my function. There's my tangent line, and that's a better picture. That's looking good. And so I feel really good about it. That went to 4. Let's do it again and only go to 2. I'm excited now. Going to 2. There's my curve. There's my tangent line, and that actually looks like a tangent line, and so we feel very good about this answer. And so you can check these answers. Sometimes you have to really play around with it to get a good picture, and I finally did get a good picture coming, basically zeroing in right on that point there. But once I did, I got a pretty good picture, and I feel good about it. Now, if I hadn't been out of time, if it'd been a test situation and I was running out of time and all I really had time for was Zoom 6, I wouldn't have felt awful about that. It's at least possible that I have a tangent line there. And so I wouldn't have felt awful. I wouldn't have felt great because I didn't have time to check it more, but I wouldn't have felt awful. And that is the conclusion of this section.